Okay, people, we are nearly there. Um, I added more bromine to this when this was cold this morning, and then added some more hydrochloric acid and turned on the heat and the stirring. All of the precipitated mercury has dissolved. All of the little bitty, almost like powder little particles are gone. And the only thing that's left is this little coagulated blob. It did all finally come together right here, which probably isn't very obvious. It's actually dissolving quite readily. There, you can see it. It's bubbling away and dissolving merrily. So hopefully before too long here, we will have all the rest of this dissolved and we can finally fucking move on. Which would be nice, because I've been doing this shit for days now. I fucking hate dissolving mercury. It's such a pain in the ass. Alright, people. So after many days of working with this shit, we have got everything dissolved that's going to dissolve. There is a little bit in here that for some reason just will not go into solution. That's fine. I was actually able to dump out all the mercury powder that was in my waste container into here, and just added some bromine to it, heated it, and let it stir until everything went into solution except for these little globs. So I'll put them in here and then dissolve them later on down the road sometime after I've made more nitric acid, which I'll have to do here in the semi-near future. But anyway, what we're going to do now is we are going to filter this solution here to make sure that we've got any little particles out of it. Of course, debris always falls into it from the fucking trees. And we are going to filter it into here. It's the only thing I've got that's big enough to hold it. And we're filtering this through a plug of glass wool because it is incredibly acidic and probably still fairly oxidizing. So plastic and glass are about the only things that I really trust to resist this. So anyway, yep, just going to do that. Should be very straightforward, very simple. Whee! Oh my god, fucking A. I hate the way these fucking things are shaped, man. Because if this thing is really full, it makes it a complete bitch to try to pour it cleanly. That's so obnoxious. I wish I could say that's like the first mercury that I've gotten on the bench, but no. No, the bench is kind of maybe a little contaminated with it. A little bit. It's fine. What pisses me off more is losing fucking mercury. There. Quit being a fucking cunt. Yeah. Anywho. So I'm going to finish this process and then I will come back here when it's done. Okay, so what I've done is I've kind of switched to just pipetting the base in because I was very spooked by the fizz. Fizz means aerosols, and aerosols are very dangerous. They're not quite as dangerous as dust, I don't think, because dust can get blown around, settle on something, and easily lifted off it again by some disturbance in the air. Dust remains a continual threat. Aerosols, the big problem with them, other than potentially breathing them or getting them in your eyes or your mouth, and not even necessarily realizing it, because aqueous solutions can make very, very, very tiny little droplets that are easily carried a good distance. But when they land on something, they tend to, so long as it's not a human body, they tend to just kind of dry out and form tiny little spots of whatever the hell was dissolved in them, and you can usually see them. I've seen them on the stir plate many times, man, even from solutions that I didn't think were fizzing. But I can also tell from the bench where it's been, and it usually doesn't go very far. It will stay kind of mostly in a halo around this, but it will get on everything. So yeah, beware the fizz, people. The fizz is dangerous. Anywho, so this thing has started doing something fun. I've been able to create little mercury tornadoes in the center of the vortex. Isn't that so cool? Oh, I love it. You better be focused, you piece of shit. I'm getting a new phone, by the way. Thanks to my roommate, who was very kind in helping me out. Mercury tornado in a beaker. I'm not exactly sure why it's doing this. I mean, I don't know that we're necessarily close to neutralization. It might have something to do with the density of the liquids. I don't know. But it is very cool looking. Mercury tornadoes in a beaker. Who would have thought? I certainly didn't. Although I don't know why, given how I saw how this was behaving earlier. Like I mentioned before, I switched to potassium hydroxide, by the way, just for shits and giggles. And because I don't want to open a fresh bottle of sodium hydroxide. This bottle of potassium hydroxide, which has remained remarkably intact, is several years old. But boy, I'll tell you what, whatever company made that knew how to make a good airtight seal on bottles. We've got to be getting there. Come on, you fucker. Oh, the tedium of neutralizing shit. Especially stuff that was this acidic. It just goes on and on and on, and you better not fucking fizz at me, you son of a bitch. Is it fizzing? Okay, no, there's no fizz. We got steam, a little bit of splatter. That's probably just for me. Ow, son of a bitch. Hot alkali hurts. Tiny little droplet, like, gets on my leg, burned like fire. That's okay. A good dilutant scrub always seems to take care of tiny little spots. No chemical burns today. I hope. Okay, people, so we are down to the last phase of this whole process here. Now it is time to turn this mercuric oxide into something useful. What I decided to do was to turn half of it into the acetate and half of it into the chloride. My main reason for doing that is because this time around, for whatever reason, a lot of the oxide precipitated out as a brown solid. Now, it seemed to be just a question of pH as to what the color was. When I first, if I added like solid alkali to that shit when I was making it alkaline, initially it would be covered with a yellow solid, then it would go orange, and then it would go brown. And the solution just kind of buffered itself and just kind of stayed at about a pH of 9, and until I got it higher, everything precipitated out as a brown solid. It's very curious. However, once I was finally able to raise the pH higher than that, it all came out as nice, bright, beautiful orange, just like it has every other time. Very bizarre. I could have treated the brown shit, but I mean, like, this is 79.4 grams of mercuric oxide, and this is about half of it. Okay? I was kind of done at this point. So yes, this is getting turned into acetate. The brown shit will get turned into chloride. If it's some kind of weird bromide species, hopefully the chlorine will oxidize it to elemental bromine and it will just evaporate out, I hope. You know. And if it's something else, hopefully by chlorinating the ever-living shit out of this stuff, man, we can destroy all the contaminants and get the chloride to crystallize out nice and pretty. I'm reasonably confident. Just like the acetate that we're about to make here, the chloride is fairly covalent. It dissolves in ethyl acetate, so like in both cases we can recrystallize our product from ethyl acetate. If there's any other kind of residual salts in there, they're not going to dissolve in ethyl acetate, so we have a way to separate it from any residual shit that might end up in it in the end. Anyway, there are multiple ways to purify this stuff. So what I figured is we'll turn some of this, like I said, into the acetate. This is about 80 grams. I've done this prep in a video before, but I'm going to give you guys the abridged version this time around because we still got to chlorinate the other half of it. But this is really, really simple. For every 20 grams of mercuric oxide, you incubate it in an evaporating dish in the water bath, or any kind of dish really, just so long as it's heated by a water bath, with 50% acetic acid. As I recall, the first time, like the textbook says, you got to filter this through a jacketed filter that has hot water running through it and shit. But when I did it last time, it was actually, the solution was, as I recall, virtually clear, and like there wasn't need for all that fucking hoo-ha. So hopefully we can get away with doing it the simple, easy way again this time. I don't know. We shall see. Watch it all go tits up this time, I swear to God. So anyway, all I'm going to do is, well, first I'm going to move the camera up here. There we go. And then I'm going to put this oxide that I have ground into a powder and sieved, so it's fairly fine. Put it in there. Thankfully, it's nice and heavy, and it's not a windy day. See, very pretty, very nice. Oh, mercuric oxide is done. The brown stuff is ready. I love that. Ding, mercury's ready. All right, I'm gonna add this shit in here. I don't anticipate there being much of a reaction. Oh, well, okay. Hello, mercuric acetate. You insoluble fucker. All right, let's go get a glass rod and stir this shit. All right, here we go. Stir the, oh yeah, that's right. This stuff does clump up if it's not stirred. Now I remember. It did this the last time. I guess that's a good sign. Of course, we got some tree jizz in here. I cleaned this fucking thing with like glass cleaner. I was that thorough with this fucking thing, and still there's tree jizz in it. Multiple bits. Okay, that's got to be coming out of the outside. It was pre-jizzed in. Pre-jizzed. I'm going to be very careful since I burnt the shit out of my hand and have a nice open wound here on my finger. Oh God, this channel's batshit crazy. Do as I say, kids, not as I do. Remember, I'm old, and if I kill myself, well, that's my affair, isn't it? But don't you go killing yourselves. That's not cool. I don't want to die by mercury poison. That would be a bad way to go. God. But Band-Aids on your hand are generally a bad idea for the same reason that contact lenses are, because they can trap chemicals next to the skin. And take it from me, if they get wet and you're working with something that's giving off vapor, like acidic vapor, that acid vapor, remember, acids like that are just gases dissolved in water. When they're hot, or if they're just concentrated, that vapor is the gas coming out and then condensing with water vapor in the atmosphere. And then that goes, lands on the wet Band-Aid, dissolves into the water that the Band-Aid is trapped, and then gets held next to the skin. And, yeah. If said Band-Aid is covering an open wound, because why the fuck else would you have a Band-Aid on your hand unless you're some kind of weirdo? That burns like hell. Like you would not believe. I have no idea what it would be like getting mercuric acetate and acetic acid in a wound. It would probably burn too. Like a motherfucker. Would it give you mercury poisoning? This is a good bit of mercuric acetate. Might. It might. Let's not find out. And see, it's dissolving very nicely. I don't know what the textbook's problem was. You better be focused, piece of shit. I have a new phone now, but I have more concerns about the focus on it than I do on this phone. I don't know, man. It does not seem like these cameras get better as time goes on now. It's like they're getting worse. Like all technology. Like fucking nav apps. Oh my god. They drive me crazy. What happened to, you've gone the wrong way, turn the fuck around? No, instead it's, let's give you this convoluted route. That's like, you know, going around your ass to get to your elbow. And that makes you burn like more gas and drive like 3 miles out of your goddamn way rather than just say, hey, dumbass, you fucking passed it. Turn the fuck around. 'Cause that's a goddamn hard. Oh, look, we're getting a little ring of stuff here. See? It's working. And mercuric acetate is described in the textbook as the crystals as having a nacreous appearance, which means it looks like mother of pearl. I love that word, nacreous. That just sounds so awesome. I actually looked it up on Wikipedia, and I did a little bit of a dive into it because it was interesting. Apparently it comes from what I assume is pronounced as nacre, who knows. But anyway, it's what, like the inner shells of oysters, like, you ever seen a shell that looks iridescent? It's what it's made out of. Apparently it's like little bitty platelets of calcium carbonate that are like in little layers. And it's interspersed with some like organic matrix of biopolymers to give it elasticity, and the overall effect is to make it resilient and resistant to damage. I thought that was very interesting. Ah, the smell of strong acetic acid. I like it. I don't understand people. I can't stand it. It makes my head hurt. Shut the fuck up. Get out of the fucking chem lab. Just get the fuck out. You've lost your chemist card. Alright, so there is a rapidly approaching thunderstorm, because of course there is. And we want to get this suction filtered as fast as possible, because I don't trust to leave it in this for a long period of time. And oh shit. Okay, the textbook said to chill this on ice, and it has become a solid cake of mercuric acetate. Son of a bitch. Oh, shit, man. Come on, break up, you fucking whore. Don't do this shit to me. You better not get on me either. To rinse this in ethyl acetate, it is honestly somewhat soluble in the stuff, but I think it's more soluble in hot ethyl acetate than it is in room temp ethyl acetate. This is so bad. Hopefully that will get a lot of the water out of it. I can't use a metal tool to break this up because obviously metal will react with it. Now, we've got to dissolve this and recrystallize it from hot ethyl acetate. So this is good enough for right now. I don't want to lose any more product by just rinsing it eternally. But at least ethyl acetate, while it might dissolve it, won't break it down and hydrolyze it like water will. And we'll get... Now, it's also stable in water acidified with acetic acid. Okay, so mercuric acetate all over these gloves. Okay, people, so we have our crude mercuric acetate here. Very nice, very pretty, also photosensitive, which is why I've been keeping it in the dark. Zoom in so you guys can get a better look, although there's really not much to see. There is a fuck ton of this stuff, man. I swear. We're going to go ahead and recrystallize it from ethyl acetate. This is just, you can buy this stuff at the hardware store as MEK substitute. Way more useful than fucking MEK, so I love the fact that they switched that. But this stuff is hot. It was just recently boiling. I am just going to dissolve this shit and a minimal amount of it, and then we are going to cool it down. And then we are going to crystallize it back out. Okay, move the camera here so we can get a better shot of all of this whole process. Here we go. Don't worry, I'll get a better angle as we go here. I wouldn't have thought we needed that much of it. I really hope we don't need that much of it. Oh well, look, if nothing else, it will help to get rid of the water that's trapped in the crystals, because mercuric acetate is prone to hydrolysis. Oh, hello, turn the heat off there, buddy. Yeah. How about magnetic stirring? Can we maybe have some of that now? Maybe. Maybe. I guess having the heat on actually probably is beneficial. Come on. Dissolve, you son of a bitch. No? Not quite as soluble as I thought, I guess. Oh well. If nothing else, it will allow us to better dry this stuff. Alright, what we're going to do is we are going to suction filter off the remaining solid and try to dry it. Are we going to do that? No. I think what we're going to do instead is cool this down and allow it to recrystallize, and then we're going to filter it. It doesn't look like we have a whole lot of mercuric acetate in here, which is yellow. My biggest concern is just removing the water, and if we do that, the stuff should store, as long as it's kept in the dark, essentially forever. Alright, speaking of which, there is just too much of this, and I really need to take a break from working with Mercury. I have been working with a fuckload of this stuff here, and I don't like working with one heavy metal for this long. Alright, let's put this in some ice water and let it cool off, and then we will filter out our product, suction dry it. I don't know, maybe we'll put it in the desiccator for a day or something, who knows. See what that gets us in. Oh, fuck, it's breaking down. God damn it. It got too fucking hot. Son of a bitch. Arrgh. Okay, see? Mercuric acetate. See that shit? That yellow shit? We don't want that shit. Alright, we need to transfer this to a different painting. Okay, people, so it is several days after the last clip, and I was so unhappy with that yellow shit that I got. Now, what I did was I suspended it in water, added acetic acid, and I'll be damned, it immediately turned back into a white solid. Now, this was a problem for me, because if that yellow solid was mercuric acetate, how the fuck did acetic acid oxidize it? Acetic acid is not an oxidizing acid. And so it occurred to me, hey, what if that's not mercuric acetate? What instead if it is some kind of hydrolysis product and was a basic mercuric acetate? Well, then everything would fit. And since I know that mercuric acetate can hydrolyze, I think that's what it is. In which case, fuck all with ethyl acetate. I don't know why the textbook says that. Screw that. Recrystallize this shit from 5 to 10% acetic acid, and you'll be golden, because that's all I did here. If it goes yellow like it did on me, react it with fresh acetic acid. It'll turn back white instantly. I did not let the temperature get over 60 degrees C, and I'm thinking that if the liquid is hot, that could be what's causing the hydrolysis. And the water, the other obvious question was, how is this happening in ethyl acetate? Well, it could be water of crystallization. So the water could be tied up in there no matter what. Anyway, this stuff is still slightly damp, but as you can see, there is an absolute fuck ton. Look at that shit. There's a whole lot of it. And this is just one crop of crystals, man. So anyhow, let me cover this back up so it can continue to dry. There we go. Yeah, I know that this project has had like wildly changing goals as it's gone along, but since we know for a fact you can make amalgams using mercuric acetate, you've already seen how mercuric chloride is made both in this project and on a previous video that I did that was dedicated just to that. Yeah, I'm gonna stop here. I mean, if you're trying to recycle mercury, especially if you're trying to be nice and quiet about it and not draw a lot of attention to yourself, I mean, you're going to want to keep the use of chlorine gas to a minimum, right? So, I mean, once you precipitate it out as the oxide, just make sure that the pH is high enough so that you get the nice orange oxide, and then react it with 50% acetic acid, and boom, there you go. Piece of cake. Filter that shit, recrystallize it from 5 to 10% acetic acid, and call it a day. Because this shit is, I mean, it looks exactly like it did when I made it pure straight from mercury. So this is wildly successful, and there is a shit ton of it. As for the filtrate, what I think I'm going to do, I was reading on Wikipedia that you can use mercuric acetate to make red mercuric sulfide. I might try that. I mean, anybody can make black mercuric sulfide, but making red mercuric sulfide would be cool. So we might try that. I don't know. But anyway, this concludes the whole mercury recycling thing, because you now have everything. I have showed you how to do all of this. It's nice and simple as I can possibly make it. All you naughty little kids using your naughty little amalgams for naughty little things. I have made your lives as easy as humanly possible. Bad kids. Maybe, support this channel, because, who else is going to go out of their way to try to find easy ways for you to be naughty? Anyhow, this has been a fun project. I'm kind of glad it's over. If you guys have enjoyed this, give it a thumbs up, and if you didn't like it, well, whatever. Subscribe, comment, share the video, please donate some money, and until the next one, you guys, I see you later.